Hello everyone, my name is Pritam Paul and welcome to another video. And in this video, we are going to talk about the traversal of a binary tree. Okay, so now traversing means what? Traversing means going through every element of a data structure. For example, if it is an array, then traversing means going through the every element, isn't it? Every element, one by one. So what we use? We use a for loop and we print the things. Yeah, in this way we used to do it. In case of linked list, what happens? If this is a linked list, then obviously what we do, like we used to set a pointer here which points, and then we iterate using the links, and we print it. This is the way we used to traverse, right? In case of tree, what we will do, it's a very different thing from them. In case of tree, there are, as it is a non-linear data structure, then obviously the process would be different. Okay, so traversal obviously gives the linear order, okay, of the nodes. First of all, you need to know the traversal will give the linear order of the nodes. Okay, now that means what? All nodes will be putting into one line, correct? All nodes would be putting into one line. Now there could be, like, if I draw a simple tree and put it like P, L and R. P means parent, L means left. Now either it is subtree or node, whatever it is. Okay, and R means what? R means right, subtree or node, correct? Now there are many ways to iterate. Okay, there are many ways. Now obviously there are many ways, but how many ways we are going to have? Like, if we think of a binary tree recursively, then obviously, like, there are three main tasks, okay, for traversing. Visiting the root node, obviously, which is the parent, and then left and then right. Okay, so that's why I have, like, there are three, like, this or this or this. There would be many. Like, how many? Obviously there will be a permutation. P, L and R, there are three elements. Okay, and obviously factorial 3, which is equal to 6 ways we can traverse, correct? Now what are the 6 ways? Like PLR, then PRL, then LPR, then LRP, then RPL, and then RLP. Okay, so there are 6 ways. Now among them, what are the ways we are going to pick? Now let's take a consideration which is by default generally, those who have invented all those things, they have taken in such a way. Okay, we are considering that we would be traversing the left part before the right part always. That means left will always be in the left of right node. Okay, so if we see that, then obviously PLR could be a thing. Okay, then LPR could be a thing and LRP could be a thing. Here what is happening, that RL is not possible. RL, so you can see that left node is in the right side of the right node. We are not considering this. Okay, due to that convention that left will always be on the, like, on the left part of right node. Okay, that's why. So what we are having, we are having P, L, R. Another one is L, P and R. Another one is L, R and P. That means parent, left and then right. Here it is left parent, and then right, and here it is left, right, and parent. Okay, now the thing is we have to focus on this parent. Okay, parent is left side, parent is in middle, and parent is right side. Okay, or we can see it's in the pre position, in position, and post position. Okay, that's how we are getting the names or the traversals which are called pre-order. Okay, there is no space, I'm just writing in such a way, in order, and another one is post order. Pre means what? Pre means previous. Okay, at the beginning. At the beginning, if the parent is at the beginning in the pre position, okay, then it is called pre-order traversal. And left and right, obviously left would be in the first part, right would be in the second part by the convention which we have talked about. Okay, now what is this pre-order then? Pre-order means at first it would be parent, then left, and then right. In order, left, then parent would be in the middle, that's why the in position, and then right. And post order means left, right, and p. Okay, this is the way. Okay, now let me give an example of, like, let's talk about pre-order first. Now if I give the pre-order, okay, if I have the pre-order, then what will happen? It will come to here, a would be printed out, then it is coming here, b would be printed out, and then c would be printed out. In case of post order, sorry, in case of in order, what is happening? In order means b, a, and c. And in case of post order, it is going to b, c, and a. You need to remember these things. This is the basic structure of a tree, and it's very easy to compute the traversal, that's why. Okay, but when the tree is more complex, what will happen? Let's take an example. For example, I'm sorry, a, b, and then for example d, and here it is c, and here it is f, sorry, here it is e, here it is f, here it is g, and here it is h, I, and j. Okay, so this is the tree. What would be the pre-order traversal? At the beginning, I have told you guys that this L and R means subtree or node. Subtree or node. Okay, so this L could be a subtree like this. This is the notation of a subtree. This R could be it could be also a subtree. Okay, so there are subtrees could be there. So here you can see the subtrees. For example, this is a subtree. Okay, this is another subtree. Okay, so we need to think in such a way. The subtree is also a tree, and the pre-order thing would be in a recursive form. Okay, how? Like in pre-order, what happens? Obviously the root comes first, then a would be printed out, then left subtree, and then right subtree. So in this left subtree, okay, who is the root node? Obviously b. Then b will come, then again left में क्या है? D. In the right there is another subtree. Okay, and here e is the root, that's why e will come first, then h, and then I. You understood? Similarly, in the right side, okay, in the right side, c would be the root of this subtree. Okay, c is the root of this subtree, that's why c comes first, and then obviously f, because we all know that p, l, and r, this format we are following. So f, and then obviously in this subtree g is the root node, that's why g, and then j. That's it. Okay, so in this way we can print the pre-order traversal. I will print it out for you guys, obviously, when we will start the coding. Don't worry about that. Now let me let's just focus on the topics. Okay, so what is the if I say what is the uh, algorithm or the like flow chart to implement this? Okay, so the first one would be visit the root node. Okay, visit the root node and then traverse the left subtree of the root in like pre-order traversal. Okay, obviously we can say like traverse, this is a traverse function, right? Like if I say that this is a traverse function, then obviously traverse left subtree and then traverse right subtree. Okay, this is the basic terminology or basic chronological order to implement pre-order traversal. Now let's talk about in-order traversal. Okay, for the same one. Now let's draw it. A, B, C, D, E, F. Okay, so here the in-order traversal we are going to talk about. In-order traversal. So obviously in order means what? L, P and R. The first which will come the left. Okay, so here in this left subtree, obviously B is the root, and according to the LPR formula, then left would be the first priority. Then obviously D would be printed out. Okay, now after D, what will happen? P means what? P means B. So B would be printed out. Then again on this subtree, obviously there are H is the left one, then H would be printed out for this subtree I'm talking about. Okay, H would be printed out, then E would be printed out, and then I. Okay, so this subtree is done. Now the root which is A. Uh, then obviously this subtree would be talking about. Okay, and here F is the left part, C is the root, and this is the right subtree. Then F would be printed out first, and then C, and then here obviously as it is in the left subtree, then left part, then obviously J would be printed out first and then G. Clear? Okay, so in this way in order traversal also there. Now if I talk about the post order traversal, then what is going to happen? So post order traversal means what? L, R and P. Okay, this is the thing which is going to be implemented. So left and then right and then parent, then obviously the last node would be A for sure, and left subtree and right subtree. Okay, so in the left subtree B is there, then B would be the last one. Okay, and in the right subtree C is there, then C would be the last one. Okay, now what is happening? Left then right and then root, then obviously D is going to happen, and then H, I and E. H, I and E, in this way it is going to be here. So H, I and E, and then B, and then this part, then C would be the last one. That means F is going to be the first one, then F, and obviously J, then G, and then C, and then A. Okay, C and then A. So this is the post order traversal. So this is the pre-order, in-order and post-order traversal. Okay, normally there is another traversal which we used to call as level order traversal. Let's talk about that. Level order traversal. Now what is that? Level order traversal means you will traverse by level wise. How? For example, this one. So if I talk about the level, okay, if I talk about the level, then like this is one level, this is another level, this is another level, and this is another level, correct? So obviously this is level 0, level 1, level 2, and level 3. So obviously the level order traversal would be 20, then 12, then 29, then 10, then 15, 25, 45, 12, 22, 40, and 66. This is the level order traversal. Okay, this is the level order traversal. So this is the basic thing. And by the way, for this pre-order, in-order, and post-order, if I use a data structure, then obviously stack would be there to implement all these things efficiently. Stack is needed for pre-order and in-order, and also the post-order, okay, all these things. But for level order traversal, we need queue. We need a queue to implement this one, this level order traversal, and we will be talking about it, don't worry. Okay, so yeah, these are the almost everything regarding the pre-order, in-order, and post-order, and the level order traversal. The coding part we will get into it, don't worry. Now just learn the concepts. Okay, so this is the ending part of the video. This much for today, and see you in the next video. And guys, please do hit the like button if you really like the concepts I'm explaining so easily. I'm trying to explain. And also comment down below your doubts, and share this video with your friends, and subscribe the channel if you haven't subscribed yet, and press the bell icon so that every video could be reached you through notification. This much for today. See you in the next video.